Hi, I'm Hini, and we are from Group 6. I will walk you through our F1 driver database crawler, a web scraping application that extracts Formula One driver data from Wikipedia using Python's standard libraries and regular expressions, then serves it through a Flask web application. The main input is Wikipedia list pages. And in the process, we have three layers: a scraper that crawls Wikipedia for Formula One driver URLs using 12 regular expression patterns and output into a driver.json. And using that driver.json, the Flask backend server renders the HTML page into the live website, and it also using that we have another feature using vanilla.js filter for the client side filtering. Our crawling strategy has three steps. We do the link collection firstly, scrape the Wikipedia's list of Formula One driver page and takes the correct table from that page and extracts up to 150 individual driver Wikipedia URLs. Secondly, profile data extraction. The scraper visits each driver's page individually and applies regular expression patterns to pull their information and their career statistics from the info box in the Wikipedia. Thirdly, the fallback mechanism. Sometimes the Wikipedia's info box format is not consistent, especially for older drivers. So when a statistic is missing from the individual page, the scraper falls back to the original list table, uh, fill the gap to ensure data completeness across all drivers. Here's our project file structure. Scraper.py is the heart of the project, and let me walk you through the regular expression we use to scrape the information. RE0 is the entry point of the scraper. Before we can find any driver links, we need to isolate the correct HTML table from the Wikipedia list page. The pattern targets the exact CSS class Wikipedia used for their table, and it lazily captures all the entire table, and they specify the closing table tag uh, to show where to stop. RE1 is responsible for finding the driver links from the Wikipedia list pages. It uses a hyperlink reference, and it should start, and that link should start need to have a Wikipedia article path. And here we capture the name. The name's first letter has to be an uppercase one, and following that letter, it has to be lowercase letters, including the accents. And we have another non-capturing group for other name parts, and here we specify how many name parts can be there, how many non-capturing groups can be there. There could be 1 to 3 more name parts, which means it can match up to 2 to 4 word names, and it follows a similar pattern as the first name. RE2 extract the driver's full name from the HTML title tag, um, and it may follow by a optional white space, and the first character must be uppercase followed by other letters. And here we specify that we will not include the hyphens, underscore, or pipe symbols to have a clean name without those symbols. And RE3 targets Wikipedia's standard PD class, which corresponds to the driver's birthday, and it always or almost always format to the year, month, date format. And here we use case insensitive for the HTML class using RE ignore case, because sometimes the BDA might have different cases like uppercase or lowercase. It could sometimes it could vary. RE4, um, you extract the driver's full birthplace, and here it skips any extra HTML attributes using in this part, and it captures lazy capture this the information inside the span tag. And here we use re.all because sometimes uh, the span tag might have multiple lines in the HTML. So we have to uh, capture them even if it goes on like that. RE5 matches with the nationality table cell, and here we use re.all because sometimes nationalities might always have like a flag icon, um, and we have to ignore it by re.all. And here we capture the nationality part. Um, from RE6 to RE11, we use the same structural anchor pattern to extract the career statistics, and we essentially looking for world championship career to find the right section of the info box table before capturing the statistic digit or any text. So here we capture something text, here we capture digit like that, and here we specify the related statistic could be the team, championships, wins, car number, audience, or pole positions. So also, um, there's another important part we use to skip certain words when it comes to URL extraction. It filters out many non-driver links like category pages, season articles, something like that, which are not driver links. So this using this method, it ensures we will only get the driver links and Wikipedia driver Wikipedia links. And here we use a clean function that uses 7 regular expression substitution to turn messy Wikipedia HTML to plain readable text. And here we have stripped the HTML text. We have decode the ampersand with the symbol and decode in BSP with the white space with the space character likewise. And let's move on to the live demo of our app. So here we have the web application. As you can see, we have structured all the data into a table format, and it spans up to 150 drivers. And if we go and talking about the filters, we can search for certain driver, and if we want a certain driver from a certain nationality like Hungarian, yeah, like that. And if you want American, like that. And if you want a driver called J, who's from American nationality, you can have it like this. And for teams, if we want to have an American driver who races for the um, BMW team, we don't have any driver racing for that. Um, be some other. Oh yeah, we have a we have an American nationality driver who races for this team. And if we clear out all the filters and we will go inside of one of the driver profiles, we can get this interface where we present all the information in this beautiful format, and this one corresponds to the car number of the Formula One championship. and these will give a summary of their career statistics and their personal information. If we if we want to view their uh, original Wikipedia page, we can go to their page, and as you can see, we extract information from this info box. And yeah, um, in summary, um, the scraper runs once at deploy time and saves to JSON, and the Flask reads that JSON and serves it through four routes: through index page, the detail page, filter JSON. In the API. We have API for the filtered JSON and for the aggregated stats. And we have in the front end we have used Jinja 2 templates, CSS, Vanilla.js specifically for the filters in the client side. And in summary, this project demonstrates how powerful Python's built-in RE module is for web scraping without any third-party scraping libraries. We have used two regular expressions to extract up to 150 driver information without any scraping third-party scraping library, only using the RE module. And we have used Python standard libraries, Flask, Jinja 2, vanilla JavaScript, and Railway.app for the deployment. Mm, thank you for. Okay, we have come to the end of our presentation, and thank you for watching. And the live link can be found in the description.